We looked at this f of x plus h minus f of x all over h, and we found the limit as h approaches 0 to help us calculate the slope of the tangent line. This is actually, without that limit, this is actually called the difference quotient. So we've actually, just dropping that, this expression here is simply called the difference quotient. When I've had you calculate the limit as h approaches 0, f of x plus h minus f of x all over h, this is actually what we call the derivative. The derivative is nothing more than the slope of the tangent line. We use derivatives for a lot of things in calculus. It's the first big calculus concept. This notation, this f with the apostrophe of x, that's your notation for the derivative of f of x. This is what we call f prime. So anytime you see this notation, this f with that apostrophe, that's just your notation for derivative. So, and again, we generated that formula. Remember, as we talked about, we used the two different definitions. We could calculate the slope of a tangent line. This is the generic formula. This is the derivative. That's why I had you practice this one more often than the other one. And again, we're talking about the derivative of f with respect to x. So again, the domain of f prime consists of all the x values in the domain of f. So again, if a number is not in the domain of f, it's not going to be in the domain for f prime. F prime, the derivative, is a function in itself. If you find the derivative of a function, again, the derivative is a function all in itself. It's a completely different function. The process of finding the derivative is called differentiation. So if they ever ask you to do the differentiation, you're just finding the derivative. All right? And you actually did that last night for homework. So, for example, use the definition to find f prime of x. So again, you're looking at the definition of the derivative. So here's my f of x. So again, I'm going to be using my formula, the limit as h approaches 0, f of x plus h minus f of x all over h. So in the directions, they want you to find f prime, and then we're going to use that to find f prime of 2. So remember your function notation. Once we find f prime of x, 2 is the x value. What I'm going to do with the 2 is I'm going to plug it into the derivative. And what that will actually calculate, what you did last night for homework, it's actually telling you the slope of the tangent line at x equals 2. So that's what this f prime of 2 is actually doing. You're actually finding the slope of the tangent line at x equals 2. That's what that notation is doing. To kind of relate it back to what you did last night for homework, this f prime of 2 is actually having you find the slope of the tangent line. So here's my f of x. What would f of x plus h then be? If f of x is 1 over x, what is f of x plus h going to be equivalent to? 1 over x plus h. So now what I want to do is I want to plug f of x and f of x plus h into my formula to calculate the derivative. So I want to have the limit as h approaches 0, f of x plus h, you told me, is 1 over x plus h, minus f of x, which is 1 over x, all over h. Yes?
Just like, this is a question. If you had the difference equation like x squared plus x plus 1, would it be like x plus h squared, x plus a? Okay.
Yep, anywhere you see an x, you would substitute an x. So if you had an x squared plus x, it would be x plus h to the second plus x plus h. Yep. So as nightmare of it would be, yes. Like I said, there are shortcuts to come. That's that lessons we're going to talk about next week. There's a whole bunch of rules we're going to go over in terms of finding the derivative. There are some of the shortcuts may not seem like shortcuts once we get into it, but we do have rules, and so you don't have to do this over and over again. Okay? So now, if I try and plug, remember when you try and find a limit, you always try and find a limit by direct substitution. So if I plug 0 in for h, what form do I get? I end up getting the what? 0 over 0. So now what am I going to have to do algebraically to help me calculate this limit? I'm going to have to multiply everything by what? Multiply everything by your LCD of x plus h times x. Because your LCD is x plus h times x. So simplify your complex fraction. Again, you do not drop this limit notation. You must leave this limit notation until you do the direct substitution for 0 in the end. You must, that's an operation. Just like you wouldn't drop an addition or a subtraction sign, you do not drop that limit notation. You must keep on writing it. So again, when I multiply 1 over x plus h by the LCD, the x plus h is canceled. That leaves me with an x. Minus, make sure you open up a set of parentheses following the subtraction sign. 1 over x times the LCD is going to leave me with an x plus h. all over h times x plus h times x. So any questions how I simplified the complex fraction? So now simplify the numerator. So what happens with x minus x? That's going to end up doing what? Canceling out. So make sure you distribute your subtraction sign. So that gives me a negative h over h times x plus h times x. And then what can you cancel out? Now you can simplify the fraction. You can simplify the what? H's. So I still have the limit as h approaches 0 of negative 1 over x plus h times x. So any questions on how I simplified that complex fraction? Okay. Now I can find the limit. How do I find the limit? What am I going to do? So what am I going to substitute in for h? I'm going to yeah, go ahead, Hannah.
Why did you put in negative 1, or why did you put in 1?
I canceled out the h's right here. So when I simplify that, I take h and divide it by itself, which gives me a negative 1. So now what am I going to substitute in for h? I'm going to substitute in a what? 0. So my final answer would be negative 1 over x times x, or another way to write x times x would be what? X squared. So there is your derivative. So your derivative then, f prime of x, is equal to negative 1 over x squared. That's what your derivative is equal to. So any questions on how I found f prime of x? So like I said, nothing really in this has changed since what you did last night for homework. It's just we're giving it a different name and a different notation. Yeah?
Okay, so is that the slope of the tangent line?
This is the formula. We're not done answering. This is just f prime of x. We haven't answered the question yet. Yes, Hannah? We good? No, not done. I'm not done the question yet. This is just the derivative. So now the question, they want me to now use this to find f prime of 2. So now that I know my general formula, I can find f prime of 2 by doing what? What can I plug into my general formula? Plug in what for x? 2. So I have negative 1 over 2 squared, which gives me negative 1/4. Which, what is f prime of 2? I'm going to keep on iterating this over and over again. What does that represent? That represents what? The slope of the tangent line. Or it also represents the rate of change. It's the rate of change at x equals 2. That's what you find when you're finding the value of the derivative. Always remember that. Okay? Any questions on that? And you did this last night for homework as well. We know how to write the equation of the tangent line. This is just kind of going back over what you already did last night for homework. Again, remember, you need 2 things to write the equation of every tangent line. You need to know a point, you have to know a slope. You have to always know those 2 things to write the equation of any line. Sometimes they'll give you the point. Consider that a gift. Most of the time, they're just going to give you the x value. So if they just give you the x value, you have to find the y value. So that's step 1. Find the actual point. So this actually, if it's not given to you, you've got to find the point. You need an x and a y. The x has to be given to you. So if the y is not given to you, you have to find it on your own by simply plugging the x value back into the original equation. Always find the point. Find f prime of x. Find the derivative. And then you find the slope of the tangent line. You find that f prime of a. And then again, remember, here's your point slope form. Remember, point slope form is an acceptable form. So that's how you write the equation of the tangent line. So now, just falling back on what we just did, use the results from example 1 to find the equation of the tangent line at x equals 2. Well, I found f prime of 2. What did I find f prime of 2? F prime of 2 is what? What did I find that in example 1? Negative 1/4. What is negative 1/4? Like I mentioned, this represents what? It represents the slope. So I know the slope of my tangent line is negative 1/4. So I have my slope. Now I need to know my point. A point has an x and a y value. What's the x value? The x value is what? 2. How can I calculate the y value for the point? I can do what? Substitute it back into where? F of x or f prime of x? The original equation, exactly. Remember, you go back, you always are talking about the original curve, the f of x. So what is the y value going to be? The y value is what? 1/2. So any questions on how I found the slope or the point? Now I can substitute into point slope form. Y minus the y coordinate of 1/2 is equal to m, which is negative 1/4, times x minus the x coordinate of 2. So there's the equation of your tangent line. Don't need to change it into slope-intercept form. Leave it alone. Unless for some reason you're looking at multiple choice answers and all of your answer choices are in slope-intercept form, leave it alone. Because guess what? This could be correct. Not that anybody in here would ever make a careless algebra mistake. But if you try and simplify this and you make an error, you're going to lose points. All right? Even though this is absolutely 100% correct, but if you try and do too much and you make a careless error, you're going to hurt yourself. You'll get dinged. So leave it alone. Okay? Any questions on that? So here's a different way they could ask a question. So they're telling you that f of negative 4 is 2, f prime of negative 4 is 8. They want you to find the equation for the tangent line to the graph of y equals f of x at x equals negative 4. So let's talk about what they're giving you. What is this f of negative 4 equals 2? What is that? How's that going to help me? It's the x and y value. So graphically, what is that? This is a what? A point. This is a point. So they're actually giving you the point. So again, the point is negative 4 comma 2. Hey, I got one piece I need to write the equation of the tangent line. Remember, what two things do you always need to write the equation of a line? You need to know a point. What else do you have to know? Slope. So now let's look at the second piece of information they're giving you. They're telling you that f prime of negative 4 is equal to 8. Well, like I just mentioned, when you find the value of the derivative at a particular point, what are you finding? You are finding what? Or what are they giving you? This is the slope. So what is your slope? Your slope is equal to what? 8. So now you guys go ahead and finish this and write the equation of the tangent line for me.